Hello everyone and welcome back to the Proactive Learning YouTube channel. Today we're going to go through question 23 from the GCSE Maths Higher Paper 3 from 2021. So let's see what the question is asking us. So ABC is a triangle, then we're given a diagram. D is the point on BC such that the angle BAD is equal to the angle DAC, which is equal to x degrees. Prove that AB over BD is equal to AC over DC. So quite a lot to unpack here, but the first thing that we need to realize is this is a proof. So we're not really going to be calculating numbers, angles, anything like that. But we also need to understand the fact that when it comes to what we need to prove, this fraction equaling another fraction, a nice way to sort of start off the question is to think about what formula relating to triangles include fractions. So there's two main formulas that we know about. We know about the sine rule and we know about the cosine rule. Now, does the cosine rule have any fractions? It doesn't. So the cosine rule doesn't seem quite right, but does the sine rule have fractions? And it does. So let's have a go at thinking about the sine rule now. So how does the sine rule help us here? So one way to think about it is AB is this side here, BD is this side here, AC is this side here, and DC is this side here. So here we've got an outline of the triangle when it comes to what the questions actually told us. But one useful thing about the sine rule is the sine rule, we can use it for any triangle. So we've got one small triangle here, we've got a second small triangle here, and then we have an overall bigger triangle here if we put these two triangles together. So in this case, we can do the sine rule for each of the triangles and then for the bigger triangle as well. But how does that help us? Now, the main reason why that helps us is because when it comes to these two smaller triangles, we have one side in common. So that lets us get this equal sign. But let's see that in action. Let's see how we can actually go about answering this question. So let's first have a look at triangle number 1, which we've labeled. So we've got an angle x here. So let's first recall the sine rule. So the sine rule is sine of an angle A over the side A is equal to sine of the angle B over the side B. So here, the side opposite to the angle X for triangle number 1 is the side BD. So we can write sine of X over BD. But now we also need to consider a different angle in our triangle. So let's say we consider this angle, and let's label that angle B. So in this case, sine of the angle B is then over, what's the opposite? The opposite in this case would be the side AD. So in this case, we've got some sort of relationship going on between the side BD, AD, the angle X, and the angle B. But what we want to do now is do exactly the same thing for our second triangle and try to get some sort of expression for AD again, so we can make them equal to each other. So let's have a look at triangle 2 now. So similar case here, we have the sine rule, so sine of A over A is equal to sine of B over B. Now in this case, what's the opposite to the angle X? And that would be the side DC. So we have sine of X over DC, and that is equal to, here, let's just choose this angle here and we'll label it angle C. Then we have sine of C over, what's the opposite to the angle C? That would be the angle AD. So from here, we've got two expressions now, but let's rearrange both of them so we have AD is equal to something. So in this case, what we can do is do cross multiplication for both of our expressions. So if we do cross multiplication for the top expression, we have AD sine of X is equal to BD sine of b. And then how do we go from AD sine of x to AD on its own? We divide both sides by sine of x. So then we get AD is equal to BD sine of angle B over sine of x. Now let's do exactly the same thing, but for our second expression here. So let's cross multiply again. So now what we have is AD sine of x is equal to sine of c times by dc. So we'll put that in brackets there to keep it clear. Then we don't want AD sine x, we want AD on its own, so we divide both sides by sine x, and then we get dc sine of c over sine of x. So the next thing that we need to think about now is we've got a lot of unknowns. So we don't know what DC is, we don't know what BD is, we don't know what the angle B is, and we don't even know what the angle X is. But what we can do now is think that we've got AD and AD here. So in other words, we've got two expressions that are the same. So in other words, what we can do now is make them equal to each other. So here, if we have DC sine of C over sine of X, and since that is equal to AD, that's also the same as BD sine of B over sine of X. Now here, to make it a little bit simpler, we can multiply both sides by sine of X. And if we do so, that simply just gets rid of our denominators and we're left with DC sine of C is equal to BD sine of B. But now, if we go back up to the question, we're trying to get somewhere close to here. AB over BD is equal to AC over DC. Now, do we have any of them here? So we have a DC here, we have a BD here. So in other words, we've got half of the expressions we want. We've got the BD and the DC here. But then how do we get the AB and the AC that we're after? So from here, what we can think about is using the sine rule for the entire triangle. So here, what we're looking for is somehow using the side AB and using the side AC here. So in this case, what are the two angles where their opposites are the sides AB and AC? That would be the angle B and the angle C that we've labeled here. So in that case, let's use the sine rule now. So sine of B over, but then what's the opposite of the angle B? That would be the side AC. And that would be equal to sine of C. And what is the opposite side to the angle C? That would be the side AB. So then we'd put AB here. Now what we can see here is the two expressions that we have, they all have a sine B and a sine C. So the first thing that we want to do from here is to cross multiply to get rid of this fraction, to get rid of all the fractions so it's a little bit easier to deal with. So if we do that, what we're left with is AB sine B is equal to AC sine C. Now here, how could we make these two expressions equal to each other? And one way that we could do that is by getting one side or the other equal to each other. So what we can see here is both expressions, they have a sine C and a sine B. So let's try and get the sine B and sine C on the same side. So to do that, why don't we just divide everything by sine B and see what happens. So if we divide this first expression by sine B here, we get DC sine C over sine B is equal to BD. Now here, sine B divided by sine B is just equal to 1, so we don't even need to write it. So anything divided by itself is equal to 1. Now, if you do the same thing for this expression here, what do we get? So it becomes AB, sine B divided by B, or sine B divided by sine B is just 1, and that is equal to AC sine C over sine B. But now here, we're almost at the end. How do we get sine C over sine B on one side? We have to divide both sides of this expression by DC. So that leaves us with sine C over sine B. And that would be equal to BD over DC. Then for this expression here, we need to divide both sides by AC. So that leaves us with sine C over sine B is equal to AB over AC. So we've done quite a lot of work here. So let's see what this actually means. So what we found out is BD over DC is exactly the same as AB over AC. Now, is that what we wanted to prove? AB over AC is equal to BD over DC. So not quite. So where can we go from here? So let's go back up to the top here and rewrite what we found out. So we found out that AB over AC is equal to BD over DC. What we can do here is that we can times both sides by AC, which would get us AB is equal to BD times by AC over DC. But then from here, we can divide both sides by BD now. So if we divide both sides by BD, what are we left with? We're left with AB over BD, and that's equal to. Now, if we divide by BD, this goes. So then we're left with AC over DC. And that's exactly what the question wanted us to prove. Hence, we've answered question 23. So this is a very hard question, quite a lot of complex ideas, and you need to be quite creative to get to the answer. But with more practice, you'll be able to find these creative ideas, and hopefully these questions will become a lot easier. So with that in mind, hopefully that answered any questions you guys had about this particular question. Feel free to drop your questions in the comments below. Please like, comment, and subscribe. And with that, that'll be it for today's video. See ya.